First of all, thanks for Lou for inviting me here. First time being the family, super excited to see this many people showing up at this time, during the middle of the week. Tonight I'm going to talk about machine learning the product. This is actually a piece of work I did when I was at Spotify. Happened around 2016. So before that, a little bit about myself. At the moment, I'm leading the data science team at GoEuro. GoEuro is an online travel agency like Skyscanner, but the major difference is that besides train ticket or flight ticket, we also provide bus ticket, all together. So in a way that we are more like a superset of our competitors. And our team has been working on a couple of quite challenging projects since the past. And at the moment, we have one opening for data scientists. If you're interested, let me know. Of course, hiring is always the thing. And before GoEuro, I spent around 5 years at Spotify and a brief time at SoundCloud. Most of you know what happened there. And before that, I did my PhD in computer science in TU Delft in the Netherlands, where I studied the user behaviors in large-scale peer-to-peer file sharing systems. In another word, how people used BitTorrent. All right, back to the topic for tonight. So one question, how many of you know or use A/B testing? Cool, very cool. So I would assume everyone knows about it. Okay. On paper, A/B testing is extremely simple. You start with a hypothesis. You have a user base split into control and test. However you want to split it. You develop the hypothesis into a change in your product, in your service, whatever you have in your business. Apply the change to the test group. Run it over some time period. And at a certain point, you can start measuring the effect, if there's an effect. And the goal there is basically try to establish the connection between the change you applied in your service or product to the effect you observed in the test group. However, I would like to ask, is this good enough? Of course, I would say no, otherwise I wouldn't be standing here talking, all this kind of stuff. But I would say, A/B testing tells you what actually happened during the time of the test, but it doesn't really tell you why something happened. Of course, I'm not talking about, you apply change, then something happened, this why, but the actual reason, what actually led to the observable effect. For a couple of reasons, product can be quite complex these days. And because of this complexity, sometimes even when people think they're going to apply a simple change, such change will cause lots of subsequent changes in the product, which is very hard to capture. User behavior can be complex too. This we all know. And the challenge here is that most of the time we have lots of data about our users, but at the same time we also realize that it's never possible to have everything, all the knowledge about the user behavior. That means we're really having a challenge in a constant base about logging the user data to capture this complex behavior. And last, sometimes people are in a rush, business stakeholders are in a rush, trying to push out some changes, but at the same time, we also want to test them out, and people wouldn't want to wait for proper A/B testing being run one by one, because that will take forever. That's when sometimes we pack a couple of smaller changes into one big change and roll it out and test, to see what actually happens. And all of these things will lead to this kind of situation. One change in the product, multiple changes in user behavior. Over time, changes in user behavior will lead to the effect in your test metric. So that means in order to figure out what actually happened or why something happened, we need to ask a different question. Which user behavior change actually has the biggest impact on the observable effect? And later on, I will show that somehow we can establish the link between the impact of some user behavior to the predictive power when we do the machine learning on the actual target. So apparently this is a high-dimensional problem. We have lots of different aspects of user behaviors. We try to log as much information as possible so we can improve our service over time. And our brain is not really good at this. My brain has problem when there are more than 2 dimensions. But the good news is that we have machines. Machine learning models, algorithms are designed specifically for this kind of problem. Here comes to the solution, which is very simple. What we did at Spotify was we convert A/B test into a machine learning problem. First, we should determine the type of the problem. Since for most of the, well, I would say since for all the A/B tests we run, we know exactly what we're going to test. So here we're not really talking about unsupervised machine learning or reinforcement learning. We are actually talking about supervised machine learning. So 2 types of the supervised machine learning problems. First, classification. Classification, if you're testing about retention, conversion, click-through rate, all these metrics are, on the user level, all these metrics are more like a binary outcome. If a user clicked on a button or not, if a user retained or showed up the next day or not. Naturally, we're talking about classification. Or we are talking about regression if you're dealing with metrics like lifetime value, session length, number of, let's say, streams for Spotify's case. And once we have the problem defined, we should start preparing the user level measurement. And this is actually the most critical and the most major step for the whole work, where we want to switch from the group level measurement down to the user level. Think about a normal A/B test about second week retention. We don't really have to measure much except just counting how many users you see this week will show up next week. That's it. You have the metrics. You have the statistic. However, this kind of measurement will be far from enough, for telling us what actually happened or why something happened. So that means we need to prepare lots of measures for user behavior. Given that one product change can lead to multiple behavior change, and then to reflect those changes in our data, we need to prepare lots of user level, I would say rather raw level measurement. And of course, on the user level, we will also convert from the group-wise effect, like retention, conversion, to the user level target, like a binary outcome. And from the past experience, what I observed that is we normally have way more measurements of user behavior than the changes we can anticipate. So in this case, we can capture as much as possible or capture as many different perspectives or aspects of user behaviors as possible. And naturally, all those measurement of user behaviors will be converted into machine learning features. And at a certain point, we also realized that we have to make a distinction between actionable features versus non-actionable features. For actionable features, those are the features you can influence to a certain extent by changing your product. These are all for Spotify context, like session length, skip rate of streams, or number of offline streams you have. On the other hand, when you have non-actionable features, you have country, age, gender. So I haven't seen any product that can persuade users to change this kind of things. Well, even if they do, probably you wouldn't really see much effect. So the way we use actionable features are, we actually use them to build models, as input features to train the models. And for non-actionable features, they are used to segment users. So if you have a big enough user base, you can actually have a couple of different segments. For each segment, you have one model, trying to explain what happened. So this is very much the feature engineering step for all the machine learning problems. And I would say this is probably the most critical step for the machine learning framework, for most of the machine learning framework. There's so many quotes about trying to emphasize the importance of it. Like this one from Pedro Domingos. Some machine learning projects succeed and some fail, and what makes the difference? Easily the most important factor is the features used. So back to Spotify, we probably spent over half a year just trying to build up this data set to make sure we include most of the features we want to have, make sure we want to have a proper production of the data set we can use all the time. And on the other hand, when I think about the machine learning part, it's, we used most of the off-the-shelf model. It didn't take much time at all. And we have the problem defined. We have the user level measurement prepared. Now it's time to choose the model. So I'll get into the model we used directly. So we used gradient boosting machine, GBM, and we used XGBoost for the actual implementation of it. So I would say for people working on machine learning or doing Kaggle competitions, XGBoost is not something strange at all. It used to be the go-to model if you do any Kaggle competition. And however, we're not doing a Kaggle competition. So what I mean is that for this task, pursuing the ultimate accuracy in prediction is not really the goal. But on the other hand, explaining the user behaviors is actually the goal. So that means we actually made trade-off between the power or complexity of the model to the explainability of the model. And what we care in the end is the feature or variable importance from the XGBoost model. And the feature importance is a very simple measure, quantifying how much contribution a feature you have in your data has on the final performance of the model or accuracy of the model. Of course, the higher the importance, the better or the more predictive a feature is. So for our case, we consider features with higher importance are having bigger impact on the final effect. And after all of this, you have all the models trained, you have the feature importance output. Of course, now it's time to compare all the top features, features with the highest importance, comparing between test and control. You actually see, see the difference. Sometimes you see difference in feature importance, the top features, or you see difference in the values or the distributions of those features. And that will lead to another more iterative process. Analysts will get into those features trying to understand how the product change can cause those kind of differences. And another usage of this information is that you can actually use it to derive more high-level informative metrics. So one example is if you have a model trying to predict retention, and the model picks up a couple of features, have strong correlation with retention, you can actually derive another, let's say, metric, combining all of those features into some kind of score, like a retention score. And this kind of score can be used for the future as a monitoring tool for new users or for old users. So it's much more informative than raw signals from the users. So a little bit thought on the model selection. So why we're not using linear models. So in terms of predictive performance, it's kind of like weak compared to tree ensembles. And also it requires too much pre-processing. And this is actually a little bit bad for our case, because once we have all the features curated, we don't really want to pre-process them much, because for linear models, once you have correlated features, you have to drop lots of features, and that's exactly the thing we don't want to do. And someone also asked me why not random forest, which is arguably as powerful as XGBoost or GBM, and also requires less tuning on the parameters. So the reason is, since we care more about the feature importance, and we know that when you train random forest, there's a random selection of features, when you train different trees, and this actually causes the calculation of feature importance to be inaccurate or biased. So here I'm attaching a paper at the bottom. So if you're interested, you can actually look into this symptom, and there's a correction for that. And I would say that's very much it. So before closing the presentation, a little bit final thought. So very often when people talk about machine learning, we are talking about making predictions, like deep learning these days, and we try to make lots of predictions. But sometimes machine learning can also be used for explaining the past user behaviors. And I have seen a more increasing usage of it. For example, there's a blog post, a recent blog post from Netflix. So apparently they're using a similar approach to diagnose root causes for their device issues. Because for Netflix, there are so many factors on their device, networking, different firmware, different versions, and sometimes it's a little bit hard to understand what actually caused some user experience issues. So they're also using machine learning techniques, I would say quite similar approach to sort of do the diagnosis. And I'm quite happy to take questions, now or over emails.
This. So how do you work with delayed effect? Let's say you introduce a new user interface, which is much more streamlined, it's cool, but the people are, so the effect is bad first, but after a while people get used to it and they like it. How do you deal with that?
So I would say this framework or this work can't really help on this. So I was not dealing with this effect or this kind of problem, but I get what you're saying. So I would say this is more a challenge on the design of the test. So for example, if you design the test, normally you have to decide how long you're going to run the test, right? If you anticipate the effect will be delayed, you probably shouldn't, let's say, stop the test too early. But still, this is a little bit hard to say. I've been talking to lots of product people over different companies, and it's a little bit hard to say, when something will happen in the future, because lots of changes will keep coming up. And let's say, if you only run one test at your company, and there's no other tests ongoing at all, so probably this is an easy question easy problem to tackle, easy problem to measure. But if you run if you run multiple tests all over the time, so when you observe some effect in the future, even if you say this effect is good or bad, it will be tricky to attribute the change to the test you run at the beginning, right? So, but still, I would say the most common approach I've seen is when you run A/B test, you stick with a set of standard metrics. So for Spotify, it's quite common people stick with standard metrics for retention, for conversion, lifetime value. And then at least you have a more standardized framework to evaluate all the tests.
Thanks.
Is there another one here?
Yeah, I want to ask you questions about how you build your models. You mentioned about the unalterable features and alterable features, which is the unalterable features you use to segment for segmentation for the user, and alterable features are fed into the model. Then how many models are you going to build anyway? Because there's so many unalterable features, and how can you manage all of them? So that's the first question. And the second question, why? Why don't you think the unalterable feature should not be fed into the model?
So to the first question, yes, we did have lots of models because those non-actionable features, like even if you go for country, Spotify was available in 50-ish markets. So even if you only go for that dimension, you will have like 50 models running every time. And also if you get into device, then you have another dimension, you do the multiplication. That was actually a very solid point. That was also the reason why we went for XGBoost for the model, because of the runtime performance. It runs so much faster than the Python, the scikit-learn implementation back then. And back then we didn't have the light GVM, the implementation from Microsoft, which is considerably faster than XGBoost. But with XGBoost, we can already put the model into production on a quite powerful server with lots of cores and enough memory. So given that we are not running those models in real time, or we didn't have a requirement to have the result in real time, normally it was like a daily batch or even a weekly batch. So running those models, let's say even 200 models, it was not a problem. And to your second question, why not combining all those features together to train the model? So we did it at the beginning. But we found that if you put all the features together and train the model, of course, the model will give you more or less similar results, to our case. But it makes the inspection of the features a little bit difficult, because then you have to sort of pick up all the actionable features people believe they can influence the future, and then they leave out all the non-actionable features. So I would say in terms of picking up the features, it doesn't make too much difference. I think the choice was more made for making the whole process more smooth for analysts, for product.
Thanks.
There's one here. Still the case. Yep. That was the same? Okay. Cool. Over there? Okay, sorry. Okay, yeah, if you don't mind, then I'll continue.
Okay, my question is also about the separation. So the split between the groups, so the segmentation, did you do that automatically as well, or was that a business decision on how to do the split? So let's say age groups, countries, is that something that you did like algorithmic? Is that something you have to find by the business?
So I would say it was a hybrid. So of course, if you talk to product or marketing, people already have some intuitions about which dimension will have a bigger impact. Especially for business, people would say, country is certainly a important factor, at least for Spotify case, because different countries have different, let's say, users in different countries would have different taste on music, and probably also different perceptions of the service, this kind of things. So we have a couple of, predefined, let's say, dimensions that, most of the people agree in the company. So we didn't really spend much time sort of debating or researching these dimensions. At the same time, we also had a couple of dimensions we found, over our work, because at a certain point we trained quite a few models, including all those features. We tried to pick up, the important non-actionable features for the segmentation later on. So I would say it's more like a hybrid process. But once we decided on the set of non-actionable features, we basically just okay, we freeze it and then we put it into production, then everything got automated.
Okay, thanks.
Hi, thank you for your talk. Do you have any thoughts on how you go about deploying these models in the products that you're using?
So, since this model was not deployed into the actual user-facing features in Spotify, so it was very much like internal deployment. And so for us, I mean, for this case, it was actually quite, let's say, straightforward, because we have all the data in our internal Hadoop cluster back then. Now everything is in the GCP, and we have our internal, like, virtual machines. So XGBoost comes already in a very good shape for deployment, easily parallelizable, and we can just drop it directly into the production environment. We didn't even have too much like problem with that. It was extremely smooth. It was very different from, let's say, the more traditional deployment of machine learning models that you have to sort of, do things, let's say if you do the scikit-learn in the Python, then probably you want to convert everything into Java when you do production environment deployment. So we didn't really have this problem, given that it was very much internal environment. We didn't have super, let's say, demanding, let's say, requirements. So it's like a weekly basis or daily basis. So I guess we didn't really touch on the production level deployment for this case.
Thank you very much.
Thank you.
Girl, I found it.